Hey guys, happy Friday. Hopefully you were able to finish up your solving systems by substitution with no problem. Don't forget that you can always check your work in the binder to see how you did. Today we're going to look at another method for solving systems. This time we're going to use a system called elimination. However, first let's review a little bit of substitution. So let's have two people go to the board. Since I don't have my popsicle sticks with me, you can either pick two people, or if I'm just picking two people off the top of my head, how about Felicia and Daniel, if nobody else volunteers. So take a moment, go do those problems on the board, and pause the video, and come back when you're ready. Okay, so I apologize if my work overlaps some of theirs, but let's see what you got. So for this first problem, since y is already isolated, I can put y equals and substitute that in for y. And what I'm going to get is 5x plus parenthesis x plus 3 and then equals 9. I'm going to combine my like terms and I'm going to get 6x plus 3 equals 9. Subtract 3 to both sides, I get 6x equals 6 and then x equals 1. I'm going to take that, substitute it into one of the two original problems. Doesn't really matter which one. I am going to plug it into the first one because that's a little bit easier. I get y equals 1 plus 3, so y equals 4. But remember, our final answer has to be absolute or ordered pair, not absolute values. Okay, for this second one, there was no variable solved for, so I'm not sure what variable you guys solved for. I'm going to solve for this x right here. So when I do that, I should get x equals negative y. And the great thing is that because of a 0, I could put plus 0 here. I don't have to write that, so I can just leave it as x equals negative y. So I'm going to take this, I'm going to plug it in up here. I'm going to get negative y plus 3y equals negative 4. When I combine those, I get 2y equals negative 4. Divide those by 2. Oops. And we get y equals negative 2. So then I can take that negative 2, plug it into one of the originals. I'm going to plug it into this one. Negative 2 plus x equals 0. Add 2 to both sides, we get x equals 2. So hopefully you got those answers. If you didn't, take a moment to pause and figure out where you went wrong. So today we're solving systems by elimination. This method is best when all variables are on the same side of both equations. So that would be something like here where we had x and y on both sides. Our goal is to eliminate one variable. So to do that, the coefficients must be the same number but opposites of each other. So for example, you could have 4 you could have negative 7 and positive 7. You could have 2/3 and negative 2/3. The number's the same, the sign is the opposite. So let's try this problem. Solve the system using elimination. I'm looking at the coefficients of the variables. Here I see that the coefficients are positive 1 and positive 1. Here they're positive 1 and negative 1. Well, if I look at my y's, they already have the same number and they have different signs. So I can eliminate these. Essentially what I'm doing is I'm adding these two equations together vertically. And when I do that, I get 2x. And when I add 1y minus 1y, those cancel each other out. So I'm left with equals 12. I'm going to divide both sides by 2 and get x equals 6. Well, then I have to plug that in just like yesterday. So we're going to get 6 plus y equals 10. y equals 4. Write your answer as an ordered pair, please. And that's it. Here we have another system. X plus y equals 7, x plus 3y equals 11. Oh dear, sorry. So I want same number, different signs. So if I look at my y's, they have different numbers and the same sign. If I look at my x's, they have the same number, but they have the same sign. So I could really eliminate x or y. I'm just going to choose to eliminate the x's because I already have the same number. I'm going to multiply one equation, it doesn't matter which one, by a -1. What this does is it keeps that number the same, but changes its sign. So when I distribute that -1 to everything inside, I'm going to get -x minus y equals -7. I'm going to draw a line through just to remind myself I'm done with that. So the x's cancel out. We have 2y equals 4, and then y equals 2. Substitute that into one of the original problems. X plus 2 equals 7. That would give us x equals 5. So we have 5, 2. That would be our answer. Alright, so this one's a little trickier. If I look at my variables, neither have coefficients that are the same. 2 and 4 aren't the same, 5 and 10 aren't the same. But if I start looking at the numbers, I can say, well, 2 goes into 4 twice, 5 goes into 10 twice, so I can multiply this first equation by 2. But let me look at my signs. Here they're the same. Here they're already different. So I'm going to multiply by +2, and we'll see what that does. 4x minus 10y equals 22. What that's done is kept our signs different, which is what we want, but given us the same number. So when we combine, we get 8x equals 40. Divide by 8, and we get x equals 5. When I plug that in, 2 times 5 minus 5y equals 11. That would give us 10 minus 5y equals 11. Negative 5y equals 11, or sorry, equals 1. And then divide by -5, we get y equals -1. And that's it. Your homework for today is page 128, numbers 18 through 28 even. If you finish that before the end of class, don't forget you can check your answers with a friend or with the binder, and then you need to find something else to work on. Have a good weekend, and I will see you all on Monday.